in this unit, we looked at data being different types of data. Then we looked at how data was distributed for a couple of days. Today we're going to work on explaining the distribution, like why does it look this way? We're going to get some vocabulary for how it's distributed and so on, okay? So that's going to be the focus today, getting words in place for how data is distributed. You're going to start with your small group here. I'll give you 1 minute to come up with a group and decide which one doesn't belong, but try to think of reasons any of them would not belong. We got 1 minute for what doesn't belong. These all have different shapes. One way, like I kind of imagine things when I look at it is like I imagine kind of a line, like giving a trend almost. Are you guys seeing I kind of imagine that above things. I don't know. It just gives me a visual. And you might see this come up with some of the words we're about to discuss. So we're about to get some vocabulary to use today. We have symmetric distribution. So I hope everybody knows what a line of symmetry is. What I always think is, can I draw a line right down the middle where it like folds and it match up? Now it doesn't need to be perfect for that. And what happens is that means our median and our mean end up being the same number. So the middle's the same either way, whether we pick the middle thing or we calculate the middle thing. All right? So the big thing to think about with symmetric is symmetry. I think we all know what symmetry is. All right? I'm going to point you toward the language on all these to help remember. And a side point, if this is the first time you've seen one of these things, do you think my expectation is slam dunk, everybody got it first time every time? No. But my expectation is if I ask you to try to use these in a moment, best effort, and we try to use them. If it's wrong, we adjust, and that's called learning. Okay? You know what I mean? If you don't try in a minute to like get things to match up where they are, you won't be able to learn well. So my expectation, again, is not that you've got it first time every time right here. Now we've got a skewed distribution. So instead of being perfectly symmetrical both sides, skewed is like off to the side. So if like vision is skewed, it's like a word used to mean off-center quite a bit. So I also remember I said I like to envision that kind of thing. Now what gets tough is, who can describe where a lot of the data is, left or right? Who can raise their hand and tell me, it looks like a lot of the data is generally here. Natalie? Or sorry, not Natalie. Greta?
It looks like most of it's on the right side.
Yeah, so it's over here, right? So when we say skewed, we give a direction. So I remember when I was in school, I always wanted to say skewed right, but this is actually skewed left in this case. And what that means is, would you guys agree that the median's probably like somewhere in here, the middle data? Mm-hmm. And what are these little pieces doing to the average over here? Bringing the average up or down? Down. So it's pulling the middle to the left. So that's why it's called skewed left. All right? It's tough because we see a lot of stuff to the right. I remember struggling with that a little bit until I thought about, oh, it's bringing my data down. Like if these weren't here, this would be a pretty nice little set. I should draw more squiggles on there and see what happens. Is everybody seeing that? Skewed left. That's kind of a tricky one. And then we have uniform distribution. This one's kind of, I think, the easiest one to point out. It's all the same. Uniform. Okay. And this one is maybe the most fun. Bimodal. What part of that word sticks out? As some bi, which means what? Two. So I like to think of like this. Are you seeing this general high and this general high? It's got two places where things are general. Bimodal. Okay. Two places where data is concentrated. Is this one symmetrical? I think if you cut it right there, it's pretty close. I might say it's symmetrical. It's not perfectly symmetrical, but it's like, in general, a mirror, right? Okay. Oh, didn't hit the right button there. And last one, bell-shaped. So we saw this the other day. It's kind of shaped like a bell, like this. Okay, where we got little pieces on the ends with the concentration in the middle. The mean and the median would be like the same. And is this one symmetrical? It's not perfectly symmetrical because of this, but we would still say it's symmetrical. The sides generally mirror each other. You guys seeing that? Okay? But is that one technically makes it not perfectly symmetrical, but it's symmetrical in terms of distribution still. And if you had like lots of pieces of data, like millions, 1 out of a million is like not that significant, right? So when we have more data, it makes a little more sense too. So 1 minute with your group, I want you to do a notice and wonder with our dot plot and our histogram here. in your small group, I'm going to give you a card sort. You're going to match dot plots with histograms. You're to go one at a time. One person in your group is going to make a match, and then you're going to explain it, and you're going to all have to agree on it. Then the next person in your group is going to make a match, agree on it. Next person, one at a time. Not just everybody spreading out matching. One person makes a match at a time, and you talk about it. Okay? It'll be less efficient, but you'll have more dialogue. Then, when everything's matched up, you'll use these red letters at the bottom, and you're going to assign language to your distribution. Okay? We're going to practice that. Maybe we won't be 100% first try. It's all right. You're going to say, I think it's this thing, and then we talk about it later. Okay? Now, so I'm going to show you the match. I'm going to make sure you have the match, and I'm going to work on naming them together, even though you already should have started that. So, here is number 1's match. Check your x-axis, okay? Now, where is group 1?
Oh, right.
Okay, so, as a group, what words did you use to describe this one?
Actually, bell-shaped.
Okay, bell.
Symmetrical is one.
Bell-shaped and symmetrical. That's probably spelled wrong, but symmetrical. Okay, that's all good for number 1. Group 2. Where's group 2? Group 2, how did you name this one?
We also said bell-shaped.
Bell-shaped and symmetrical. Excellent. Group 3.
Symmetrical and bimodal.
Bimodal. So I could cut it right there, and it's pretty much perfect on both sides. So and then bimodal. It's generally high over here, generally high over here, right?
Yeah.
Okay, cool. Group 4. Group 4. Kind of. Yeah, so I don't know if I name it symmetrical. It looks like it's a little bit too high right there. But I see what you're saying. It's kind of generally you could cut right there. Maybe, okay. Then what else? Anything else? Yeah. Bimodal. It's generally high over here, low in the middle. Right? Cool. That one seemed a little less clear than some of the other ones, I think. Group 5. Samesies, except this one skews left, the other one skewed a little bit right? It's not quite as even. Okay. So bimodal and symmetrical kind of, I would say skews left though. All right. Group 6. Uniform. What's up with over here? Whoops. This is group 7. What's up with over there? Why does that not look uniform then? Because I see it 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 1. What's up with that? Yeah, it stops in the middle of an interval, right? The highest here is 109. This goes all the way to 111. So it stops mid-interval, so there's less in the interval.
So it's skewed, right?
Do you see the interval and it stopped mid-interval? Yeah, that's good. I'd just like to point that one out. So uniform, is this one symmetrical? Can I cut it like right in the middle?
Yeah.
Yeah. Yeah, that's still symmetrical. All right. I'm using my best penmanship right now. Okay, we didn't have a group 8, so back to group 1.
Bell-shaped.
Bell-shaped, okay, we can talk about that.
And it's
What about this though?
to the right.
Yeah, skewed right, so not bell-shaped actually.
Oh, my bad.
So we're just gonna say no. That's not your bed. That's good. That's good. Mistakes are expected. So this one little data point pulls the middle all the way over if we do an average, right? Skewed right. How about this one?
That's not us. That's not
Group 2. Where's group 2?
Here, if the same as the last one, just skew to the left.
Yeah, skewed left. The middle of the data wants to be like right in here, right? But it pulls it left.
Indeed.
This one, group 3. What do you guys think?
Okay, cool.
Symmetrical. Yeah, I could cut it right there, right?
Oh, it's not right.
Yeah, trimodal. Maybe that's not a word we had, but are you guys seeing these 3 spots? So we don't have trimodal as a word. I would just say symmetrical, and maybe consider something like trimodal. And that's good. That's a good talking point because watch this. Were some of them a little trickier than other ones?
Yeah.
Yeah, some of them. And then did they all require the same vocabulary, or did some of them require maybe two to explain better? We could use up to two of them, especially symmetrical or skewed. And then I would say, though, some of them we got to talk about. Maybe that's kind of bimodal, but maybe skewed. We can use that language to help talk about distribution better and better, okay? Maybe it just doesn't fit a definition perfect. Sometimes that happens. So what I'd like you to do, by your group number, 1, 2, 3, 4, 5, 6, I want you to try to come up with a real-world situation that would give you the data that you're given, okay? So you're gonna have to look at your data and say, this data could be a collection from this thing. Okay, that's what I want you to do next. Just for your group number. Put a little bow on it for today, okay? To be symmetric or bell-shaped, all right? Perfect, left to right. It's split it right down the middle. To be skewed, it's going to pull it right or left. To be uniform, all the same. And to be bimodal, two different areas of height. I think maybe two other great examples, because I think bimodal is hard to like just think of examples. Two other examples that I thought of. Let's say there's a restaurant that only does breakfast and lunch. And you're like seeing how many people are there. When are the two busy times going to be at that restaurant? Breakfast and lunch, and like that middle time there might be a little low. Okay. The other one I thought, anybody do fishing in here?
Oh, I do.
Like there's some fish species like sturgeon where you can only keep them if they're like this small size or this huge size and not in the middle size, because that's probably best for their breeding. You guys, there's some fish species in the ocean. There's some like that too. I think some groupers are like that. You can keep little ones. You can keep huge ones. You can't keep in the middle ones because those are the ones that are breeding. So those are two places I thought about bimodal data. Kind of like, it's a harder one to see. Okay, so what we're going to do now.